what you're doing is plotting pH versus milliliters of titrant. And you all have done titrations where you added, the basic one we did in Chem 1A was the one where you put HCl into a solution and then you add sodium hydroxide to it. And they react and eventually it turns phenolphthalein red and you read your burettes and get the volumes and you do your calculations. Okay? So you know all about titrations. I'm not going to give you graph paper on the quizzes, but I'll ask you to plot various points on the titration curve. Okay? I'm going to set up a basic problem here. The one you did. I don't ever ask you on quizzes. But if I take, let me take 20 milliliters. We're titrated with, well, so the numbers won't look all the same. What concentration? I'm going to use NaOH. And I'm going to say 0.100 molar NaOH. And one of the first things you always want to ask yourself when you're doing titrations oh, by the way, this is the original solution. NaOH is referred to as the titrant. You're titrating with NaOH. That's the titrant. Titrate with the titrant, I guess. The reverse problem, of course, would be if I took NaOH and titrated with HCl. Okay. The reason we didn't do that titration, the titration in that sequence, we did it in the laboratory. I had your instructor mention that to you. I mentioned it. When you're titrating and using phenolphthalein to detect the endpoint, which is not the same as the equivalence point, by the way, but that's what you detect in the laboratory. When you add the base, the solution turns colorless to red. We call it pink, light red, but pink isn't really a color, as you know, so we call it light red or something. You get the color change from colorless to light red. That's easier to see when the color appears than it is to see it when the color disappears, because you're not sure. Your eyes play tricks on you when you're trying to see if the color has disappeared. Or if you're adding reagent and all of a sudden the color is there, your eye tells you there's definitely been a change. Okay? There are indicators where it would go in the opposite direction. Some of the indicators, for instance, go from orange to red. That's sort of subtle change. But you can see red to orange, orange to red, so you can go either way with that type of indicator. We use indicators to detect the endpoint. We did NaOH to titrant just because of the indicator system we used. But we can work this either way. We could add HCl to the NaOH solution or vice versa. And one of the questions is, what is the volume needed to get to the equivalence point? Now the equivalence point is the theoretical point where you've added equivalent or stoichiometric amounts of both reactants. But the other thing we talked about This is the experimental thing. The equivalence point is the theoretical number that we can calculate just by doing stoichiometric calculations. So that's the theoretical number. The end point is what you physically detect in the solutions, change in color of your indicator. Ideally, these two places in the titration should be the same. Okay? But when we do calculations, we always work with the theoretical number. And what we're doing is this old calculation, and you may have said volume concentration, you took it, but I always like to say liters A, molarity A. And it almost looks like the dilution equation we were talking about a few minutes ago. I guess that was a few minutes ago, it's gone off the board. The big difference here is, since I'm working with molarities, I have to put what? A mole ratio. Okay. But these are going to be essentially 1-to-1, because if I write the reaction here, it's a 1-to-1-to-1 mole ratio. Okay. And again, I'll say something about polyprotic acids as we go along. But this is the first calculation you always want to do, because I'm going to give you problems just for convenience. I'm not going to let you pick the points, otherwise I'd have to do hundreds of calculations because everybody picked different points. So I'm going to calculate and say, so I'm going to say things like, calculate the pH after you add so many milliliters of titrant. Okay. And so one of the things is, knowing where the equivalence point is, it tells you the type of calculation you want to do. So for this problem here, you take 20 milliliters times 0.2 equals X times 0.1, and you get what? 40 milliliters. Okay. So that's the equivalence point. And you know at the equivalence point, how much HCl do you have? None. You've used it all up. You have no sodium hydroxide. You've used it all up. The only thing you have is sodium chloride solution. And you already know the pH of a sodium chloride solution. So if I were plotting the titration curve, here's 0, 2, 4, 6, 8, 10, 14 up there somewhere. I just got tired of doing numbers, but this must be my pH scale. Along the side, bottom here, I'm going to plot volume, okay? And I need to get up to 40 milliliters at least. 1, 2, 3, 4, 5. Yeah, I'll make that. So I'll call this, I don't have 41, so I'm going to call this 10. 1, 2, 3, 4, 5, 20. 1, 2, 3, 4, 5. 30. There, got my points marked off. So at 40 milliliters, I know my pH up here is going to be 7. Because that's one of the reasons you like to know where the equivalence point is. And you can calculate the pH before you start the titration. Because you added 0 milliliters, you know that the concentration of H plus is what? 0.2. And then you get your calculator out, you say the pH is about 0.7, minus, it says, calculator says minus 0.698 or something, so about 0.7. So the pH starts out down here, somewhere in here. It gradually works its way up to there. And just for the heck of it.
Oh yeah, Doctor.
Yes.
Just make sure when you're asking what is the volume needed, is that the total volume like in your container, or is that the volume
That's the
added?
volume you have to add of the titrant, because we're calculating the volume of the titrant.
Okay, and so
That's what we're plotting down here. So the information I give you is the volumes of titrants added.
So I guess I'm confused. Why is it 40 milliliters is your
Because here it is. Milliliters of titrant is the horizontal axis. And I just calculated that I needed 40 milliliters of NaOH to get to the equivalence point.
Okay.
That's the volume of the titrant. Acid, base. I used A and B because those are most of the problems we do, but I could pick other letters. But that's essentially it. So I want to know what the pH is after I've added a certain amount of titrant. I said the assumption in these problems is the volumes are additive, but the volume of the solution is not going to be 40 milliliters here, right?
Okay, so okay.
Whereas down here, the volume of the solution isn't 0 because we started with 20 milliliters. We just calculated the pH of that particular solution. But now I'm going to ask you, one of the points I always ask, not always, but sometimes. At equivalence point. What the heck does that mean?